Hi, I'm Ryan Deans, the FSI and AI lead at DDN. Today, we want to talk about how DDN are enabling quantitative trading organizations to think differently and push boundaries of what's possible for our technology. Today, I'm joined by Moise, our CTO for Financial Services, and James, our SVP of Products. So just to make a start, next slide. We're seeing in the industry that data sets are exploding, models are growing more complex and larger, and to stay ahead, quants need to think differently and experiment like never before. And it's extremely powerful and performant technology that's becoming a critical enabler to this. The technology is opening up more possibilities, enabling quants to explore more, disrupt more, and explore new territories. A very simple proof point to all this is actually the GPU investment we're seeing in the industry. From a technology perspective, we are seeing organizations needing to adopt a performance tier above what they currently have, or risk falling behind, which is great for DDN, as high performance and at scale technology providers. So we're going to go a lot more deeper into this today. We'll make it short and sharp, but first I'll provide you with a brief introduction to DDN for those who are not familiar with us. Next slide. So DDN are a super focused HPC and AI storage and data intelligence company. It's what we do and it's what we've been owning for years. We're proudly an engineering and support focused company. In fact, 2/3 of the company are in these functions. With this comes continuous development and innovation, and of course ensures we are super focused on customer engagement for these extremely critical environments. Next slide. We collaborate with some amazing organizations that utilize our technology to achieve groundbreaking things. Two significant customers to call out, Jump Trading, an extremely successful customer of ours in the trading vertical, and NVIDIA. It's worth double clicking on NVIDIA. That reference is pretty significant. NVIDIA, for 9 years now, have used DDN exclusively for all their internal systems and at scale. That's 9 years, right? They continue to test, push, and collaborate with us, which helps further our technology capabilities for everyone in the market. So as a summary, when you think of DDN, it's performance at scale, proven with industry leaders, and engineering innovation and customer focus. With that, DDN 101 over, I'm going to pass you over to Moise.
Thank you, Ryan. So I've been lucky enough to work very closely with some of these firms and in this particular industry. I was the Global Chief Innovation Officer for London Stock Exchange Group, which included our assets like LCH. As some of you may know, LCH clears approximately 1.3 quadrillion, which is over $1,000 trillion a year in assets. So these transactions obviously led us to understand how quant trading really impacts the financial world and the role that the infrastructure and low latency plays into it. And I'll touch on some of that. Along with some of the risk calculations that you would do in quant trading, you're also looking at high frequency trading. And thankfully, DDN works across the board with all of these companies, whether it be on the front end with broker dealers that are doing different sorts of trading algorithms to the post-trade chain that includes all the CCPs, CSDs, and settling banks and everyone else. We will touch on some of that today, and of course, we are available to discuss this in detail with you if this is of interest. Next slide, please. So if we look at how we would define quant trading, obviously every step along the way, there are risk calculations and low latency calculations that impact the flow. And for almost everything today, you would be using different types of AI algorithms to either do predictive analytics or define the different types of calculations that need to occur in real time. And as you see in this workflow, you'll notice that storage or data remains at the center of it. may have heard that Jensen Huang spoke to the fact that DDN is at the heart of every AI deployment that NVIDIA does internally. The reason for that is because the role that data and relevant data plays into this equation, where every single step you are persisting incoming data in low latency to your platform, and then you are retrieving that data to do different types of calculations. And this cycle goes on and on. This particular workflow shows exactly that. And where DDN plays a major role in this is where you will find that we provide extremely low latency platforms that includes the hardware, and that is really highlighted by the fact that 74% of the 2024 IO 500 supercomputing file system performance plays were all DDN. So DDN is at the heart of almost every major supercomputing and low latency data deployment out there on the planet. And along with that, our Infinia platform, which is really the software-defined storage platform, comes into play because when you are persisting data or retrieving data and actually leveraging it to drive insights, you may have different types of applications which were all written in using leveraging different formats, protocols such as POSIX file-based protocols versus object-based S3 or GCS protocols. There is almost no other platform, to my knowledge, that allows for a single platform to allow access to that platform through any of these protocols, multiple protocols, and the ability to deploy your data estate into a hybrid cloud environment. That means that some of your data may be sitting on premise, which of course for low latency or for risk calculations, due to regulatory reasons, much of that data or much of those calculations need to happen either on premise and on sovereign soil, or some of that data may reside in different clouds, such as GCP or AWS or Azure. Your ability to be able to leverage all of that data in a timely fashion is extremely critical to driving these calculations in time and being able to report or being able to ensure that you're not carrying excessive risk on your books. So that's where our platform really comes into play and provides the capabilities that we're speaking of. Next slide, please. So in this particular case, we have many of the top high-frequency trading firms that are leveraging our platform today. And as you would see from this particular workflow, one of the core things that most of these require is their ability to ingest massive amounts of data from multiple sources, whether those be ticks coming in from different exchanges. You may be co-located with those exchanges, and different types of information coming in from different news sources. Your ability to correlate that information, bring it into a singular platform, create what we call a data ocean, and the concept behind that data ocean is that you want all of your data to reside in one place. So first of all, you're not duplicating data multiple times, because as you know, data duplication leads to reconciliation, which is a very time-consuming process. So if you have your data in a single place, you have the ability to create what in the industry would be known as the golden copy, and you don't have to replicate or reconcile that data. Now that can move down the chain across every single function, and that function gives you the ability to understand whether you're doing simple processing, whether you're doing model development, pre-trade execution, where you're checking for different types of limits on each participant to ensure that they have the margins to be able to place that trade. Then providing that trade functionality where you want to make sure that you can match the order book in real time, which normally would be in sub-milliseconds, definitely under 100 microseconds, with the infrastructure that my team and I have deployed in the past. And then get into the entire post-trade component. That post-trade component obviously is extremely critical. We may speak to that in a second. And you're going to continue to do iterative development. As you can see, every stage of this workflow touches your data, either modifies that data or simply retrieves it and leverages that data to drive intelligence. And at DDN, what we really concentrate on is data relevancy. My colleague James is going to speak to this in a second, because the way we've designed the DDN system, it is extremely unique, where we have what is known as key value based system. So we have designed the system from the ground up, leveraging key value stores, such that if you look at most other systems out there, what you have is the ability to define metadata, a handful of different metadata tags that allow you to search for different types of characteristics within your data. With DDN's platform, we give you almost unlimited metadata tags. So you can have thousands of metadata tags, which are extremely critical, because your ability to find relevant data in the shortest amount of time possible depends on the fact that you can search for certain things, and only those things are surfaced as quickly as possible within, sub-millisecond types of ranges. Next slide, please. And this particular slide speaks to the fact that when you're doing model training, most people think that running AI models simply depend on the get performance, where you are retrieving data and you're leveraging that to drive insights. That's absolutely true. However, when you're doing model training, or as we saw in the previous workloads, when you're persisting data, because you have these massive pipes bringing in all kinds of information into your systems, your ability to persist that data is extremely critical. And DDN provides that persistence capability at least 30% faster than any other platform out there. So the graph on the right shows you that when you start to ensure that your persistence is actually keeping up with the information flow that's coming into your system, that truly means whether you're dropping packets on the floor, and if you are, then you're losing information, which means you're losing money at the end of the day. So that ability to persist that data along with retrieve that data are both extremely critical. And DDN platform is one of the few, if not the only, that allows you for that to occur. The industry standard for this, by the way, is when you're persisting data, such as you're checkpointing for your models and stuff, when that is happening, most of the time your GPUs, one of the most expensive resources that you have spent money on, is sitting idle. The industry standard for that is approximately 30% idle time for these GPUs. What DDN ends up providing is 95+% data persistence capabilities, which turns into GPU utilization. So your GPU utilization is as close to 100% as it can be, which you can imagine directly impacts the bottom line. Next slide, and I will introduce my colleague James, who really leads our product development lifecycle here at DDN. He can speak to some of the capabilities that I touched on. James?
Yes, thanks, Moez. I run DDN's product management group, and I want to talk a little bit about one of the architectures we provide to financial customers, and give you just an insight into how it does what it does. And as Mo was just saying, and I come across this a lot, our financial customers, they obviously care about performance, but performance is not just one thing. We talk about performance in a multitude of different contexts, in terms of throughputs, in terms of metadata, in terms of IOPS. And one thing we tend to find from financial customers in particular is that they're concerned with serialized workloads where each iteration in a workflow is dependent upon a previous iteration. So it's difficult to parallelize. In that case, you really want low latency response to get things through this serial pipeline. And then on the other end of the spectrum, also from financial customers, we see lots and lots of processes trying to attack, read, write a single shared file. And these are problems for conventional file systems. And you might be familiar with, NFS file systems. These are kind of shared POSIX file systems. They do give a non-siloed even access to data, but they don't do so in a high-performant way in the context of what we're speaking about here. Extreme performance, extreme low latency, extreme IOPS, and extreme high throughput. So take a look at this architecture diagram. It's very simple, but just to outline the differentiation between ourselves and even conventional, but also distributed file systems using NFS. The first thing in that diagram you should notice is that our client, our intelligent client, is sitting right there next to the applications at the top of my diagram there. And it's communicating in a fully granular manner with all the storage systems at the bottom of the diagram. And these storage systems at the bottom, we've shown 2 in this picture. NVIDIA runs 48 in front of each of their file systems. One of our largest social media customers runs close to 100 in parallel, purely linear scale-out parallel file systems. But I say the real clever stuff is in this client. And I just want to give you a little hint about what's going on here, about how we get these latencies down and how we get these throughputs up. So firstly, this client is installed next to application, typical in the compute systems, whether they be Intel, AMD, or GPU systems. And they present a POSIX mount point for the application. And that means that the application doesn't have to change, right? Whether it's using NFS previously, just carry on. And it's going to be very, very safe with our Xscaler client. It will no different, no changes needed. But once the data is running through our file system, that's when the changes happen in a positive way for performance in all these different aspects I've been talking about. So the way that works architecturally is the client takes the bits and bytes, the data from the applications, it essentially chops them up very, very fine grained and then sprays them across the storage infrastructure that we've got there, where they're held resiliently, resilient against failures of drives, failures of controllers, etc. And the cool thing is that entirely coherently and consistently, any other client on what could be a massive supercomputer can read that same data and it will get the data directly from those servers. Now, this architecture here contrasts with NFS because, as you see from the picture, there's no back-end file system. The back-end file system you see with NFS is needed because they haven't got an intelligent client like we have. So the client is moving data to a server, but then the server needs to act intelligently and go and find that data. And so you need an extra network. And that adds complexity, it adds latency, it limits scalability, and it reduces performance ultimately. And this data path we've got here in this picture, which we entirely own from the client, the application, through to the storage servers, this allows us to drive the maximum IOPS to limited numbers of threads and reduce the latencies for writes and for reads, even when they become highly parallelized. In fact, we can saturate our storage environment even with a single file because we've done such a good job at parallelizing the locking architecture of our file system. So that's a little brief sort of view about how we build a highly performant system. So it's not an NFS system. We use our special intelligent client. We span the network and we span linearly a scale-out storage environment running on flash. We support NVIDIA systems, and we've been supporting those and been the primary supplier of storage into NVIDIA's environments. And through that relationship, we've been optimizing for their containerized environments, for their multi-railed client systems, DGXs and HGXs, optimizing for InfiniBand, Ethernet, and NVIDIA's Spectrum X. And we consume that network in an extremely efficient manner, reducing load on application systems, maximizing throughput through the network, and obviously maximizing the performance of the storage backend. Everything is scale out. We do start small, just 2U, a very small appliance, and then we expand to extremely large systems, and I'll show you a picture in a minute. But everything is extremely coherent, and we can pack as much as 100 petabytes into a single rack with that dense. So extreme density, all flash, scale out, really no limits in terms of scalability. Let's go to the next slide and look at some other options about how we can build out our system. And the important thing to note is that while I've showed you some appliances, and you see some more there on the right in conjunction with NVIDIA's Blackwell systems, we also run in pure cloud, in neo clouds such as Lambda, such as Vultr, and also in public clouds like Google, GCP. So if you're running large-scale GPU systems, you've got every choice you want to get the best parallel file system, whether it's on-prem with DDN appliances, even third-party hardware can be supported, also in neo clouds and recently in public cloud, particularly with Google's AI service. Next slide, please. And just one more slide, just to give you an idea about how we scale and the benefits of scaling with DDN. Often our customers do start small, 100, 200, a handful of hundreds of GPUs, and often the expansion is unknown, but inevitably customers do expand. And the nice property of our parallel file system is that we can expand linearly without really any complexity at all, simply adding more of these units. This picture is just showing one example from our reference architecture built in conjunction with NVIDIA. Here you're seeing a data platform able to support well over 4,000 GPUs at maximum performance, maximum reads, maximum writes. That means very fast data loads, very fast model loads, and extremely fast checkpointing. And that's not all. So if you look at our reference architectures, you'll see complete solutions developed in tandem with NVIDIA, including networking options, etc., around our solutions and their solutions at really any scale. Start small and have no worries about how you scale. When you scale, we're going to be with you right there and keep it easy and linear as you grow. And to conclude, let's go to this final slide. If you've enjoyed listening to myself and Moez and Ryan about what we can do at DDN to help you in your AI journey or reduce your latency for your financial workflows, then there's more things you can do. First, please do reach out to us. Go to ddn.com. You can click a button right there and speak to us, even individually if you like. Download our white papers, recently developed, very modern white papers, very applicable to this era of Blackwell and high-frequency trading. And also, our whole team has been very active in building extremely relevant posts, particular to financial services, around the data path, around optimizing for key trends that we're seeing in financial services, and how you can apply data intelligence in your data platform to see you through safely and securely for the next few years as we go through this rapid growth in AI in financial services. Thank you very much.